Thank you for joining the U.S. Army Corps of Engineers Northwestern Division for today's Missouri River Basin Water Management Conference call and webinar. Those invited to attend include congressional representatives, tribal, state, and local government officials, emergency managers, local levee sponsors, and the media. Nearly 900 invitations are sent for this call each month. We recently held our public meetings, and we'll provide the information on that as well. My name is Eileen Williamson, and I will be moderating today's call. Slides from today's call are available on our website at www.nwd-mr.usace.army.mil/RCC and linked in today's press release. These calls are recorded and placed on the Defense Video and Imagery Distribution System at www.nwd.usace.army.mil/MRWM under Public Meetings. Your participation acknowledges your consent to be recorded. For the convenience of our media representatives, the final slide in this presentation includes each speaker's name, title, and contact information. The lines have been placed on mute, so when we get to the question and answer period, to unmute your line to ask a question, you'll need to press *6 or use the unmute function either on your computer screen or your phone or both. And please state your name and the organization that you represent before asking your question. Do not place your call on mute or on hold, to go on mute. And if I ask, please use your phone's own mute function. Today's agenda includes Doug Cluck from the NOAA Climate Center, Kevin Lau from the Missouri Basin River Forecast Center, Missouri River Water Management staff with the runoff forecast and reservoir regulation details. And with that, I will turn it over to Doug Cluck.
Thank you very much, and thanks to the Corps on inviting me and Kevin to this monthly call. I'm going to go over if we can start with the first slide, or second slide actually. That's just me. I do work for NOAA, the National Oceanic and Atmospheric Administration. More specifically, in case anybody really cares, the National Centers for Environmental Information within that. So we keep tabs on the climate and can report things like this to a lot of folks as it's happening, so to speak. There have been some changes, and that's a good thing. Since the last time we had this call anyway, I think that was in March, and we were looking at a pretty desperate situation. I'm not saying we're still not desperate in some places, but I'm going to say that very recent, I'll say precipitation activity has helped some. So this is looking back 90 days to more or less the beginning of February. And on the left, you see the departure from normal in terms of temperature. And we've seen slightly below normal in most places and greatly below normal temperatures as you go further to the north and east, a little bit, well, just outside really most of the Missouri Basin. But for the most part, the Missouri Basin area has been below normal in terms of temperatures for the last 90 days once it's averaged all out. On the precipitation side, it's important to understand that these maps sort of ended, let's see, today's the 5th, 2 days ago. So it doesn't incorporate all the precipitation that has happened over the last 24 to 48 hours. So keep that in mind. Percent of normal precipitation, 4, but still, we're still looking at a 90-day period here. We're even with that precipitation, because I have it up on a different screen, just kind of looking at things, we're still sort of lacking in terms of the longer term, as we all should expect, for precipitation in the basin. Now, the more brown, red type colors you see are where we're seeing below normal precipitation, or have seen below normal precipitation up through May 3rd. And when you see the green and purples and blues, we're above, in some cases, well above normal. But most of that is confined over the last 90 days to North Dakota. There are places in South Dakota and places in portions of Montana and a bit in Wyoming that have been above, but really that's the minority of the region. Next slide. Looking at the latest 30 days, quite a change here. Just looking at the 30 days in terms of normal temperatures first on the left-hand screen or left-hand graphic, you see much below normal temperatures up to, if I can read that correctly, 10 degrees, up to 10 degrees below normal, where they've had a series of blizzards and really just cold temperatures, which oddly enough are somewhat expected during a La Nina year. That's what we talk about, El Nino and La Nina a lot, and sometimes it actually comes true in terms of temperatures and precipitation. So temperatures have been, again, for the most part, below to well below normal in we'll just say April. Looking at the precipitation a little more closely, you're seeing areas that have gotten worse, like portions of eastern Colorado, Kansas, maybe southwest Nebraska, and maybe far northern Montana, but also areas have gotten a little bit better, more of South and definitely North Dakota in terms of percent of their normal precipitation, and that sort of line straddling Wyoming and Montana. Quite a few storm systems have come through and dumped appreciable amounts of snow and rain most recently. So much so that the Red River, obviously not in our basin, is having some major problems. Next slide. Okay, just overview from a model point of view. There's a lot of inputs to this to give you some idea of soil moisture, which is something we're going to have to overcome before flows sort of get back to normal again. And this takes time, and it takes several precipitation events over a long period of time to usually get the soil moisture levels, if you will, back up to an appreciable level that we have, if you will, normal runoff. Wherever you see kind of that yellow and darker red colors, it's worse. And wherever you see green, it's wet. Okay, so dry, red, green, wet. And just like we just talked about, Red River up there, sort of almost focused on the Red River in a way, really having a wet time recently. And the soils, for the most part, remain dry. Now, at the surface, if you just had rain, it's going to be wet. But you go down a foot, you'll be talking to people who are digging post holes and things like that. They'll say, yeah, the surface 4 to 6 inches is pretty wet, but it's dry as a bone and powdery beneath that. So that's what I'm talking about in terms of improving the soil moisture over a long period of time and over an expansive area. Okay, next slide. So here's the outlook for the total amount of precipitation that we should be seeing. And I should probably change that. I should have changed that to May 12th. Anyway, through the morning of May 12th. All right. So that's about a week from now. That's an accumulation of precipitation, several storm periods, or I'm not actually sure, but probably a couple different storms moving through to cause all of this precipitation during this period. Again, the closer you get, or the darker reds and purples mean more precipitation, and blues for that matter. So blue to red and all that. Where you see white and light green, that's pretty negligible precipitation. So western Nebraska, Colorado, southern Wyoming, not a lot, and even western Kansas, really not a lot of hope in terms of substantial precipitation. As you move east, the eastern part of the basin and portions of the northern basin, it does look like there'll be an active storms during this period, which is good for that part of the basin anyway. What else do I want to say about this? Oh, the other thing I want to say about May and really June is we should be getting this kind of precipitation during this time of year. If we don't get it, we're even worse trouble than we already are in terms of drought. Okay, so May, June are super important in terms of overall precipitation for us all. We should expect good precipitation in a normal year. Now, let's move on to other outlooks. This is a mostly good view of week 2. That means May 12th through the 18th, not this next 7 days, but the 7 days following that. So we're looking out a ways. We're going to see a big warm up next week, and that's going to continue for the most part through the second week. But some colder air coming in to the west. Okay, so below normal, you see below normal temperatures forecast on the left-hand graphic there across almost the entire west. Again, I'm not going to say it's a bad thing. If we can accumulate a little more snow, I know if you live out there, it's kind of dreary, but if we can accumulate more snow and dump a little more precipitation generally, that's good. Right-hand graphic shows that most of the basin, for the most part, shows the likelihood of above normal precipitation during that week 2 period. We do want to see that. We want to see this continuance of precipitation. We don't want the spigot to shut off when it's supposed to be raining in May and June for sure. We'll probably have plenty of that as we get into the summer. Let's move on. Here's a look at May, the rest of May, if you will. I think they've pegged it pretty well in terms of temperatures being sort of below the probability of temperatures being below normal to the north, where you see the blue colors on the left-hand graphic, and sort of warmish as you move to the south, southwest. This is indicative of a La Nina pattern. This is not overly surprising to see as we move through May. Precipitation again looks positive in terms of we're not having a major, well, it's not positive for the Red River Valley, don't get me wrong, but it is positive for most of the Missouri River Basin, which needs precipitation generally across the area. Note though that the below normal stripe, if you will, isn't too far away, and the fluctuation here there could be a fluctuation of a few hundred miles, which is pretty common when these things actually materialize during the month. So the further south and west you go, worse conditions get. I'll just put it that way in terms of recovery from drought. Next slide. Looking at a 3-month period. Now this is averaged out over 3 months. Doesn't mean May, June, and July are all going to be the same way. It just means when you average all 3 months out, this is what we think is going to happen. Okay, so left-hand graphic, not great. We don't want above normal temperatures because that means a lot more evaporation, a lot more evapotranspiration, meaning plants and everything else are shedding water as fast as they can. The other thing we don't want to see is that bullseye of dryness probability, above the normal probability of drier than normal conditions across, again, most of the basin except for North Dakota, eastern Montana on the right-hand graphic there. Let's go to the next slide. And again, pretty much the same thing, June, July, August. This would be the summer. We'll just say the summer. Don't want to see a heat dome sort of create itself over the west like this is sort of indicating may happen. Now, those are probabilities. If we say there's a 60 or 70% probability, it still means there's also a 40 and 30% probability it's not going to happen, which is, pretty sizable too. So anyway, right now we're looking at heat across the nation, but mainly focused in the west, and a large portion of that in the Missouri Valley, Missouri Basin, as a matter of fact. The even worse indication here is that we'll have below normal precipitation during that period over the entire basin. I hope we're really wrong. I hope this is one of those times where you can say, "Oh, good, those guys were wrong about their seasonal forecast." We in many cases we don't like to put this stuff up, but that's what we're being told. Next slide. Here's a drought update. This does include, well, it includes some of the precipitation that's happened more recently. The image on the left is the current drought situation as of this week. Okay, it was released this morning, this drought map. You still see areas in Nebraska with a D3, meaning that red area, and in Montana and bits of Wyoming. And D2 is nothing covers a substantial area of the basin as well. Those are all levels of drought severity, if you will, and but most of the basin is under some sort of drought. So we're still hurting, and we need to see these May and June rains materialize. The change to the map, that map on the left, is on the right. So where you see green colors, it's gotten better, not gone. It doesn't mean it's gone. It just means it's gotten better in terms of drought amelioration is the fancy word to say, or drought sort of diminishing. Where you see yellow, however, over the last 12 weeks is where drought has gotten worse by various categories. So the darker the hue there, the worse the degradation of the drought situation. Next and probably last slide. Nope, it's not the last slide. Anyway, here's the drought outlook through the end of July. You can see that the forecasters in this case pared back drought substantially across almost the entire basin, really. Again, I'll cross my fingers, hope this comes true, but I will say, when is our next seasonal? Our next seasonal outlook comes out on May 19th. I would wait until then to make any decisions based upon this map. That's all I'll say about it, other than it has this is a lot of paring back, and there's a lot of expectation for rains and precipitation basically to occur for that to happen, and we'll see. I'll keep my fingers crossed. Then the final slide, and I think it's a summary. Yeah, so we're hanging on to La Nina this year through the summer. We don't know if that's going to hang into the fall or not yet, but La Nina is what we had the last few years, and it tends to have at least in the southern part of the basin, southern and western part of the basin, it tends to have a dry and warm aspect to it during, well, all year round, but really in the summer as well, spring and summer. So La Nina is not necessarily our friend. Mountain snowpack certainly was better than actually say 2 months ago when we showed that, probably better than last month too, because we've had some substantial snowpack in there. Maybe Kevin will mention that a little bit more. Recent precip has helped, but we still have a long way to go. And of course, drought has already done a lot of impacts, and it'll take a long time for recovery in some places. Short term, it's kind of temperatures are sort of a mixed bag. There's going to be some warmth, and that's going to be realized in the eastern part of the basin, cooler moving into the west. Precipitation is slightly favors above normal. That's good. Long term, not so good. Above normal temperatures and drier than normal conditions are what the current outlooks say. Again, that'll be updated on the 19th of May. We'll see what it says. We don't want to lose any more ground to drought. So keep your fingers crossed, and hope that we continue this, if you will, wet period that we shouldn't be experiencing this time of year, because this is the wet time of year for most areas. And there is the link and everything else. If you ever want to get onto that webinar, let me know. Doug.Clark@NOAA.gov, and I'll hook you up. Thank you.
Thank you, Doug. And next we will go to Kevin.
All righty. Thank you, Eileen. Can you hear me okay?
Just fine.
Okay, great. All righty. Well, like Doug said, on behalf of NOAA, and for me, on behalf of the National Weather Service, I wish to thank the Corps for the invite to participate on these calls. So snowpack conditions, oh, you can go to the next slide there, Eileen. Thank you. Snowpack conditions in the upper Missouri above Fort Peck and in the Yellowstone are getting close, I think, to their seasonal peak accumulation. A cold and wet April has slowed the melt in the upper elevations. And as Doug mentioned, it's also actually provided some additional snowpack in the higher elevations. A little late snow accumulation there. So we're just now getting to the seasonal peak accumulation, I believe, there in the upper Missouri and the Yellowstone. Current snow water equivalent, that's the liquid that's contained in the pack, in both the upper Missouri and the Yellowstone still remain, though, below the average 30-year peak that typically occurs in April. So we're still below average for the upper Missouri and the Yellowstone mountain snowpack. The North and South Platte mountain snowpack, they are also nearing their seasonal accumulated peak. This year's North Platte snow water equivalent is close to the 30-year average, while the South Platte snowpack is peaking well below the 30-year average. So of all the mountainous areas, the North Platte is closest to being about normal. There are no flooding concerns at this time due to the expected mountain snow melt going forward. The May water supply forecasts that are developed by the National Weather Service were issued this past Monday, 3 days ago, and the latest water supply outlook for the period May through September indicate a much below normal mountain runoff year for all of the mountains, with the exception of the North Platte. The North Platte, the May through September runoff is expected to be near the 30-year average. But again, for most of the mountains, we are below. April, as Doug mentioned, April was a very wet month for the state of North Dakota, and for the extreme northern area of South Dakota. There was a late season snow in mid-April that placed anywhere from 2 to 4 inches of snow water equivalent. Again, that's the amount of water that's contained in the pack. So it laid down 2 to 4 inches over the Dakotas, and then that was then followed by a couple of systems of heavy rain. So the wet April has led to a continued flood threat, not only along the Red River, which is not in our basin, but also within the James River Basin. And our concern is primarily in the South Dakota Reach. We currently do have moderate level flooding occurring in the Columbia, South Dakota Reach, and flooding to some degree is likely to occur from Columbia all the way down through Mitchell as this water slowly routes its way downstream. So I would not be surprised if we have a few more locations along the middle reach of the James River there in South Dakota go into flood as we get to the end of May. As expected, as advertised, there have been several rounds of flooding to occur in the lower basin, primarily in the state of Missouri. In fact, even today, we have ongoing flooding along some of the smaller tributaries in eastern Kansas and in the state of Missouri. The graphic that you see here on my one slide shows the locations as well as the severity of the flood risk over the next 90 days through the end of July. And so on again, off again flooding will occur in the lower basin meaning eastern Kansas, the state of Missouri, a little bit of southeastern Nebraska and southern Iowa over the next 3 months. And thunderstorm activity drives this sort of flooding in the lower basin, and it's typical. We have a typical risk again in 2022 for this to occur. But for most of the basin, most of the Missouri River Basin, though, the flood risk for 2022 is very much reduced due to the ongoing drought that Doug mentioned. The latest drought monitor, again, as Doug said, was released this morning, and it shows in excess of 70% of the Missouri Basin remaining in some category of drought. And so from a flood perspective, you might say that's good news. So thank you. That concludes the National Weather Service Flood Potential Brief.
Thank you, Kevin. And I will turn the call over to John Remus, and then he will pass it to the rest of his staff. John?
Thank you, Arlene. Thank you, and thank you to Kevin Lau and Doug Cluck for their insights. It's always very helpful. Good afternoon, everyone. I'm John Remus, Chief of the Missouri River Basin Water Management Division. Our office is responsible for regulating the Missouri River mainstem reservoir system. I will provide some general remarks, and then I will turn the discussion over to my senior staff for more detailed information. I want to again assure everyone in the basin that the Corps of Engineers remains fully committed to our flood risk reduction mission, protecting people and businesses when we can from significant flood events that pose a threat to human health and safety. Floods can and will occur regardless of basin or system conditions. This includes ice-induced flooding during the during the winter freeze-in and the spring breakup, which is past us now. With the mild weather and ongoing drought, the risk of widespread systemic flooding is relatively low. Also, widespread thunderstorms in the lower Missouri River Basin can and do occur. As Doug and Kevin said, runoff from these large storms in the lower basin cannot always be mitigated by the operation of the mainstem reservoirs. Further, it is important to understand that the volume, timing, and location at which runoff enters the system significantly impacts the timing and amount of releases from the reservoirs. Each runoff season or flooding event is unique. Care should be taken when comparing one event to another. The 2022 Upper Basin runoff forecast is forecasted to be below average. Ryan Larson and Mike Swenson will provide more details as to how this will likely impact operations of the system. But basically, we are anticipating continuing our water conservation measures throughout 2022 and probably longer. The conservation measures are reduced flow support to navigation and minimum winter releases. The Corps of Engineers understands the importance of the Missouri River in providing water for irrigation, municipal, and industrial uses throughout the basin. We try to operate the system to meet the water supply requirements of the basin to the extent reasonably possible. There is presently and will be adequate water in the reservoirs and in the river reaches between the reservoirs and below the system to serve all of the water supply needs. I want to remind everyone that the Corps of Engineers does not provide or guarantee access to the water. Maintaining access to the water is the individual facility owner or operator's responsibility. We will continue to monitor the river conditions and weather forecasts and make operational adjustments to the extent possible. We will continue to meet our statutory obligations to operate the Missouri River mainstem reservoir system for its authorized purposes, as described in the Master Water Control Manual. We will also comply with all federal laws and the provisions of the 2018 biological opinion. I want to again remind everyone that there will not be a flow test from Fort Peck in 2022. The Corps of Engineers remains committed to compliance with the 2000 biological opinion, including the Fort Peck flow test. The runoff forecast and projected pool elevations that Ryan Larson and Mike Swenson will be discussing are based on the best available information. Actual conditions may be different. This concludes my initial remarks. Thank you very much. I will now turn the discussion over to Ryan Larson.
I'm on slide 17. The 2022 calendar year runoff forecast, which is highlighted in red, was lowered since our last meeting to 17.8 million acre feet, 69% of average for the upper Missouri River Basin above Sioux City, Iowa. If realized, this runoff amount would be between a lower decile and lower quartile runoff, or the 23rd driest in the historical record. I am now on slide 18. The below average runoff forecast for 2022 reflects current drier than normal soil moisture in the upper basin and below average plains and mountain snowpack. As seen on this slide, we saw below average runoff during March and April when we typically see the plains snowmelt, and we are expecting below average runoff during the next 3 months when we typically see the mountain snowmelt. Moving to slide 19. The late spring blizzard and several rain events brought much above average precipitation to northern portions of the basin, as mentioned earlier. This graphic depicts the percent of normal precipitation during April. The purple shading indicates 200 to 400% of normal precipitation across much of North Dakota and northern South Dakota. Moving to slide 20. The much above average precipitation that occurred during April improved soil moisture conditions in North Dakota and northern South Dakota, as depicted in the graphic on the left. Despite soil moisture conditions improving in portions of the basin, drier than normal soil moisture conditions remain over much of the basin, as shown in the graphic on the right. Now moving to slide 21. As more stations in the upper Missouri River Basin monitoring network come online, we can start using the data to improve various products, such as the modeled soil moisture that was shown on the previous slide. The graphic on the left depicts soil moisture at 5 depths, 2 inches to 40 inches below the surface, with a station near Carrington, North Dakota. Beginning with the top plot, the blue line shows the soil moisture at a depth of 2 inches. Notice the sharp increase in soil moisture on April 20th, when the plain snow from the April blizzard began to melt. You can also see several other sharp increases from additional snowmelt and rain events occurring on April 25th and April 29th. As you move to deeper depths or down in the graphic, increases in soil moisture become more gradual and require more precipitation over longer durations. I am now on slide 22. The mountain snowpack appeared to have peaked in late April, but recent storms and cooler temperatures have resulted in additional snowpack accumulation. Snow over the weekend increased the SWE in both reaches, with the snowpack in the above Fort Peck and Fort Peck to Garrison reaches currently at 86% and 95% of their normal peak, respectively. In summary, the 2022 calendar year runoff forecast is 17.8 million acre feet, 69% of average. I will now turn it over to Mike.
Okay, thanks, Ryan. Gavin's Point releases averaged 24,200 CFS in April. Releases are currently at 19,000 CFS and will likely remain at that rate for a few days before gradually increasing. Flows will be adjusted as needed to meet the downstream targets. Moving on to slide 24. Slide 24 shows the system storage is currently at 48.3 million acre feet, 7.8 million acre feet below the base of the annual flood control zone. With respect to the monthly simulations or monthly studies, the basic simulation uses the runoff forecast that Ryan just discussed. Due to the amount of variability in precipitation and other hydrologic factors that can occur over the next several months, we also develop an upper and lower runoff that are then used in the upper and lower basic simulations. These simulations provide a range of reservoir elevations and releases that may be expected under the different runoff scenarios. The discussion to follow will focus on the basic or most likely runoff forecast. Information on the other simulations is posted on our webpage. Moving on to slide 25. And looking at the upper 3 reservoirs, Fort Peck, Garrison, and Oahe are currently 11.4, 9.2, and 12.4 feet below the base of their respective flood control pools. As shown on the basic forecast, Fort Peck Reservoir is expected to peak near elevation 2223, which is just slightly higher than its current elevation. Peak releases are expected to average about 8,500 CFS this summer. Garrison Reservoir is expected to peak near elevation 1831, about 3 feet higher than its current elevation. Peak releases are expected to average about 19,000 CFS this summer. Oahe Reservoir is expected to peak near elevation 1597, about 2 feet higher than its current elevation. Peak releases are expected to average about 27,000 CFS this summer. Although it's desirable to have the 3 upper reservoirs rise during the spring forage fish spawn, runoff so far this spring has been insufficient for that. Under the basic forecast, Garrison and Oahe reservoirs do rise during May, but this will be dependent on timing and distribution of runoff. Moving on to the next slide. Slide 26 details the master manual system storage checks. The service level is used to determine releases from Gavin's Point Dam to support navigation and in combination with the bank stabilization and navigation project to help provide the downstream navigation channel. We are currently providing minimum service flow support based on the March 15th storage check. For the minimum service level on the basic simulation, Gavin's Point monthly average releases range from approximately 24,000 CFS to 28,000 CFS. Releases will depend on downstream conditions and will be reduced in response to downstream flooding. However, the effectiveness of the reservoir system to reduce peak stages along the lower river diminishes as you move downstream due to the travel time. The service level for the remainder of the navigation season and the navigation season length are based on the July 1st system storage. Under the basic forecast, flow support for navigation would be at minimum service after the July 1st storage check, and there would be a shortening of the normal 8-month navigation flow support season of about 2 weeks. Next slide. Annual generation at the mainstem dams under the basic simulation is 7.3 billion kilowatt hours. The long-term average is 9.4 billion kilowatt hours. And the last slide in here is slide 28, which shows the Missouri River Basin weekly update, which is found on our website at the address shown on the top of the slide. This webpage gives a general overview of the current conditions in the Missouri River Basin and is updated weekly, usually on Tuesday morning. Thank you. That concludes my remarks. I'll turn it back to you, Eileen.
Our next update will be June 9th at 1 o'clock. Again, these are the names and contact information for our speakers from today. We'll go through the question and answer period, alphabetical order by state. Please state your name and organization before asking your question. You'll need to press *6 to come off mute, or if you happen to have used your computer to dial in, you may be enduring the double mute, which means you've been muted on your computer and potentially your phone as well. So just make sure that you're not double muted. Before we jump into that, I did have one question two questions that were submitted online, and so I'm going to go ahead and ask those first. One of them, these are both for John. They come out of Kansas City, and there's the question is to explain to the Kansas City audience what it means when they've visibly seen so much rain with respect to drought conditions and the drought report. How does that translate to the Kansas City area when they have been seeing so much rain?
I'm not real sure I understand the question, but the drought is something that we watch throughout the entire basin, and our operations at the project are based on right now hitting navigation targets from Sioux City, Iowa, Omaha, Nebraska City, Nebraska, and Kansas City. We adjust our flows to meet those targets. If we're getting rain in the lower basin, we will have less release because we need less release to meet those targets. We also are watching flooding on the mainstem Missouri River, and if that is forecasted and we can do something about it, we will also adjust for that. I'm not really sure that answers the question, but I'm not sure what the question was asked.
I think that covers what they were asking. The second question is, what does this mean for long-term conditions as we head into the summer, and what this might mean for reservoir and river use of any kind of water management issues the public might encounter? And again, this is coming from the Kansas City area, so it may also be related to some of the tributary lakes in that area.
Again, we are in a water conservation mode, so we will meet the targets, which are right now, as Mike mentioned, minimum service flows at the various gauges. As the lower basin dries up, as it usually does in the summertime, that means there will be less water in the river. From a navigation point of view, we're at minimum service, so navigators may need to load lighter in order to get through. some of the shallow areas. And there may be some recreational impacts as boat ramps and marinas may be having access issues in the lower
Thanks,
bay.
John. Thank you. Okay, so now I'm going to go in alphabetical order by state. We'll start with the state of Iowa. And again, *6 to come off mute. Kansas. Missouri. Montana. Nebraska. North Dakota. South Dakota.
Lee Strubinger with South Dakota Public Broadcasting.
Go ahead.
I was just wondering if I could get a quick quote from John. You know, when it comes to other maybe kind of La Nina years, how does this one sort of kind of shake out when it comes to water management up in this area?
Well, you know, I don't really have an answer to the La Nina part of that. We are, you know, following our guidance in the master manual, and right now, compared to other droughts, we're kind of on par right now with where we were during the last extended drought from 2000 to 2007. So we're not in what I would call uncharted territory here, but I'm not really sure how La Nina. I can't really answer that part of that question.
Sure. Thank you.
I'll chime in just for a second. This is Doug Cluck from NOAA. So La Ninas and even neutral years, which are not El Nino, with those two types of atmospheres, if you will, and oceans, as far as that goes, sort of lend themselves to, are sort of similar sometimes in terms of how they may affect the Missouri Basin. The problem with El Nino, La Nina, and what we call neutral in the Missouri Basin, and there's been several studies about this, is that unless you're at some of the higher peaks in the West, the relationship is pretty small. So I know I said a lot about La Nina and things we can expect, or we hope we can forecast based upon La Nina or El Nino. And I know people have their feelings about one way or the other, but when you crunch the numbers and look at it closely, we generally see that the best relationships are in the higher elevations of, let's say, northern Colorado to Canada. And the relationships between La Nina, El Nino, and neutral are much less. And so we can have drought and we can have, massive flooding from a La Nina year. Generally speaking, El Ninos are a little warmer and generally speaking, a little can be wetter, especially in the spring and summer. And I'm just gonna, that's really rule of thumb and very broad brush. La Ninas are a little more unpredictable, and maybe what we should say are a little more variable in terms of their swings from one end of the extreme to the other. I don't know if that helps at all, but and if you ask me how the flows work in the river, I'll leave that up to the hydrologist to give you answers.
Thanks, Doug. Any other state of South Dakota? I did have one submitted from South Dakota. The question is, with lower than average hydropower available, are there minimum power levels contracted to WAPA, or do they have to deal with what is produced and make adjustments and buy power elsewhere?
Mike, can you address that, please?
Eileen, could you repeat the first part of that? I missed what you said at the beginning.
Yeah, it says, with the lower than average hydropower available, are there minimum power levels that were contracted to deliver to WAPA? Or do they have to deal with what is produced and make adjustments and buy power elsewhere?
So yeah, we schedule what we need water-wise, and that equates to some energy that we, essentially provide to Western, and they deal with whatever we give them in terms of energy generation.
Okay. And then next up would be, thank you, Mike, would be any questions from the state of Wyoming? And any others out there? Last call for questions, *6 to unmute. No, I had a few folks call me beforehand, so I just want to make sure that I got them covered before I hand it back over to John. Think you're up, John.
Thank you, Eileen. Again, I want to thank Doug Cluck and Kevin Lau for helping us out on this call. I'd like to thank everyone that dialed in. We continue to do one more of these scheduled in June, and then we will do them as needed for the rest of the year. So I have to say thank you again, and stay safe. Bye.
Thanks, everybody. This concludes today's call.